You might think bridge piers are simply dropped straight into the riverbed, but in reality, the water must first be pushed aside. It sounds impossible, yet you drive a tightly packed ring of wooden piles into the riverbed, forming a temporary cofferdam. Then you pump out the water inside, creating a dry construction site. To stabilize the piles, you drive them deep into the riverbed until they reach solid rock. But there's another problem. Water seeps through the gaps between the wooden piles, so you build a second ring of cofferdam outside the first. The space between the two rings is filled with mud and mortar. Once it dries and hardens, leakage stops. However, as you pump out the inner water, external water pressure pushes inward, threatening collapse. So you brace the structure with wooden supports before fully draining the water and clearing the silt. You then reinforce the foundation with crushed stone and mortar. Once hardened, you can begin stacking the bridge pier above. The gaps between the pier stones are filled with lime mortar, bonding them into a solid mass. After removing the temporary cofferdam, you wait for high tide and use boats to transport massive stone beams between the piers. As the tide recedes, the beams settle precisely into place. This is the floating beam lifting method. Flat stone slabs are laid atop the beams to form the bridge deck. Railings are added on both sides to protect pedestrians. Then a covered corridor is built to shelter both bridge and travelers from wind and rain. You've invented the covered bridge, but too many piers obstruct boat traffic. So when building the next bridge, you construct a wooden support frame in the river and build a massive stone arch across it. Every brick must fit perfectly. Once the wooden support is removed, the arch stands by its own structural strength, carrying the heavy bridge above. Yet during floods, the bridge sides block water flow, so you carve flood relief openings. Now you've created the single arch covered bridge, greatly improving navigation. However, on wider river sections, arch construction becomes challenging. If the arch is too high, it's inconvenient for travel, too low, and it weakens load capacity. So you combine pier and arch techniques, integrating them into a hybrid structure. Though it appears to reduce span, it actually enhances strength. You design the bridge grand and imposing, reserving flood relief openings. The upstream faces of the piers are shaped into wedge-like cutwaters, splitting the current smoothly to reduce impact. Finally, you carve two guardian stone beasts to protect the bridge. Congratulations, you've built Anshan Covered Bridge, located in Chengdu, Sichuan. Though destroyed and rebuilt multiple times, it dates back to the Yuan dynasty and was one of the 4 Chinese bridges that left the deepest impression on Marco Polo.